All right, guys, welcome to your flipped classroom for lesson 5.6. I've got another super simple lesson. As long as you've got Desmos in front of you, either on your phone, on your app, or if you're at a computer, you can pull it up on Desmos.com. But we are going to look at graphing linear inequalities in two variables. All right, so we're going to graph inequalities. Now remember, inequalities are problems that have those greater than or less than symbols, or the greater than or equal to or the less than or equal to symbols. So they look like equations, except for the fact that instead of equal signs, they're going to have those greater than or less than symbols. All right, so essential question, how can you graph a linear inequality in two variables? All right, let's see. Example number 1, tell whether the ordered pair is a solution of the inequality. Now hopefully this is really ingrained in your mind. You had a couple of these on your test yesterday. If an ordered pair is a solution, it is going to make the inequality true. So we are going to plug the ordered pair that is given to us into the inequality that is given to us and see if it creates a true statement. So again, remember, the first coordinate is always my x coordinate and the second coordinate is always my y coordinate. So in place of x, we're plugging a -2, plus in place of y, we're plugging a +2, and we're bringing down the rest of the problem. So -2 plus 2 is 0, and then we bring down is greater than 0. Now, is that a true statement? Is 0 greater than 0? It is not a true statement, so the final answer is no. This is not a solution. -2 is not a solution to this inequality. All right, take a minute, do letter B, and then start the video again. For this problem, our x coordinate is -4 and our y coordinate is -1. So 5 times -4 minus 2 times -1 is less than or equal to -1. So 5 times -4 is -20. A -2 times a -1 is a +2, and we bring down the rest of the problem. -20 plus 2, the signs are different, so we subtract and take, and we get -18 is less than or equal to -1. Now remember, this is negative numbers. So is -18 less than or equal to -1? Absolutely. Okay? I would rather have -$1 in my bank than -$18. So -18 is most definitely less than -1. So this ordered pair was a solution. Now, let's move on to graphing inequalities on a coordinate plane. Step 1, super simple. Plug it into Desmos. Step 2, copy it onto graph paper. Now, pay attention to the line and the shading. Here's what makes inequalities different than equations, okay? If your symbol is just greater than or less than, you're going to have what I call a dotted line, all right? You might think of it more of a dashed line, but either way, it's not a solid line. It is a dotted line. If your symbol is greater than or equal to or less than or equal to, then your line is going to be solid. So you want to pay attention to that. Desmos is going to do it for you, but make sure when you transfer it onto graph paper that you put a dotted or a dashed line. Then you're going to notice shading on Desmos. Okay? Here's what you have to understand. There's not just one ordered pair that is going to make an inequality true. There is a whole lot of ordered pairs. So you're going to shade in the area that has all the solutions, all the ordered pairs that would make your inequality true. So pay very close attention to the shading, because that also has to be included when you transfer from Desmos on to graph paper. So let's look at example number 2. Graph the inequality in the coordinate plane. So open up Desmos, plug x is less than or equal to -4 into Desmos, and then transfer your line, dotted or solid, transfer your shading, okay, transfer points, all of that good stuff onto your graph paper. And then do the same thing for y is greater than -1. All right, pause the video, take a minute, plug those into Desmos, put them on your graphs, on your notes, and then hit play again. Now this is what your graph should look like. If I graph the line x is equal to -4, I am going left to -4 on my x-axis. I'm plotting a point, and since this is a vertical line, I don't really have to have 3 other points. All right? Notice that the line is solid because the symbol was less than or equal to. And then notice that the shading is to the left. Now let's try this out. Let's pick a point to the left of -4. I say we pick this point right here that we see, which is -6, 0. All right, so let's test the point -6, 0. If I plug -6 in place of x, is it less than or equal to -4? Is that a true statement? Absolutely. -6 is less than or equal to -4. So that is why all of my shading is over to the left, because all of those points that fall in that shading would make that equation true. Now, same thing for letter B. This was a very simple horizontal line. We went down from 0 to -1 on the y-axis, plotted a point, and notice the line is dotted because this symbol was just greater than. And the shading. Now, I tend to like to test 0, 0. So let's test 0, 0 and see if it makes a true statement. If I'm going to test 0, 0, in place of y, I'm going to plug a 0. Is 0 greater than -1? Absolutely. And that's why they shaded on top of 0, 0. They shaded on top of 0, 0 because it is a solution. It does make the inequality true, and so would any other point that you choose from the shaded region. Now, let's go a step further. Letter C and D. Now, these are equations that, if we did not have Desmos, we would be putting them into slope-intercept form. But we have Desmos, so I want you to pause, plug these into Desmos separately, and then transfer them onto graph paper and watch what happens. Hopefully this is what your graph looked like. All right, we need 3 points on a slanted line. So we've got one at -4, 0. You've got one at -6, 2. You've even got one at -2, -2. So whatever 3 points you chose, it doesn't matter as long as they fall on this line. The line was solid, again, because the symbol is less than or equal to. And the shading, all right? Let's test 0, 0 because I like 0, 0. If we plug 0, 0 in, we have 0 plus 0 is less than or equal to -4. So 0 is less than or equal to -4. Now, is that a true statement? Absolutely not. 0 is not less than or equal to -4. So notice, they did not shade on top of 0, 0. They shaded away on the other side of 0, 0. All right? So that's one way to figure out where your shading should be. Draw that line and then test your point. Test 0, 0 because it's easy to test every single time. If it's a true statement, you shade on top of 0, 0. If it is a false statement, you shade on the other side. Okay? So that is one way. If you did not have Desmos for some reason, that is how you would decide where your shading goes. All right, letter D. We've got a point at 0, 0. We've got a point at what I believe is 2, 1. We've got a point at -2, -1. Again, as long as you have 3 points and they fall on the line, you're good. Notice this line was dotted because the symbol was just less than. And when they tested, well, you can't test 0, 0 on this one because the line goes through 0, 0. So let's say we test 2, 0. If we test, and actually that would be 0, 2. We've got x is 0 minus 2 times y, which was 2, is less than 0. That is -4 is less than 0. Is that a true statement? Absolutely. So notice that is why they shaded on top of. When you find a point that makes a true statement, all of your shading is going to be on top of that point. So again, make sure you have your lines correct. Make sure you have your shading correct. Now let's look at the ever dreaded word problem. We're going to write and graph an inequality that represents the amount of red peppers and tomatoes you can buy. Identify and interpret a solution. Now notice it says a solution because with inequalities there's a lot of different solutions. Now it says you can spend at most. So I pretty quick spend at most. I cannot spend more than $12. So I know that I'm spending less than or equal to 12. Because at most, I can spend the full 12, but I can't spend any more than that. So I know my symbol is less than or equal to. On red peppers and tomatoes for salsa. The red peppers cost me $4 a pound. So I'm going to use 4 and I'm going to use P for peppers. And the tomatoes cost me $3 per pound. So $3 T for tomato. And of course, I'm not going to be multiplying these two things together. All right, $4 for peppers per pound and $3 for tomatoes per pound. I'm not going to be multiplying. I'm not going to be subtracting. I'm not going to be dividing. I'm going to be adding. How much do I spend on peppers? How much do I spend on tomatoes? And it cannot be more than $12. I'm going to move this over just a little bit. Now, of course, for Desmos, we're going to have to use x and y. So we can change this to 4x plus 3y is less than or equal to 12. So go plug that into Desmos. Pause the video. Go plug it into Desmos. Put it on your graph paper, and then let's see what happens. All right. If you plug that into Desmos, again, you've got points to choose from. There's a point up here at 0, 4. There's one down here at 3, 0. See, I don't know that another one. We've got one at 6, negative 4 down here that made it. My line is solid because the symbol in my problem was less than or equal to. And of course, the shading. The shading, we tested. And let's not test 0, 0 because it asks us to interpret a solution. So let's pick a different point that falls in the shading. How about we choose negative 2, 2. Negative 2, 2. So we've got the ordered pair, negative 2, 2. Now, remember, the X represents my peppers, and the Y represents my tomatoes. Now, this one could be a little tricky because you can't buy negative 2 peppers. So if you were to choose the ordered pair negative 2, 2, basically your interpretation would have to be that you would buy no peppers and 2 tomatoes. Okay, so if you, I need to work on my spelling here, so sorry. Tomatoes. All right, so if you were to choose the solution negative 2, 2, this is how you would interpret it. Since you can't buy negative amounts of peppers, you wouldn't buy any peppers, and you'd buy 2 tomatoes, and that would be the most you could buy. Now, if you picked a positive, like we have 1, 1 right here. All right, let's say you picked the solution 1, 1. Well, that means you can buy, again, the X is my peppers and the Y is my tomatoes. That means you can buy 1 pepper and 1 tomato. Okay, so you got to work on understanding what you are finding and how to interpret it, especially on these word problems. But guys, that's 5.6. That is how you graph inequalities. Very similar to graphing linear equations, except you got to pay attention to your lines. If they're dotted, if they're solid, and there is shading that happens because there are a lot of different answers that would make an inequality true. So we shade on our graph all of our possible answers. All right, I want you to do one more thing for me. I want you to go back to example number 1, and I want you to write down your favorite Thanksgiving food. What is your favorite food to eat at Thanksgiving? All right, I will see you tomorrow.